Okay, imagine this. You're building something massive, like a global music streaming app. Hundreds, maybe thousands of developers, all working on the same code. How, how do they possibly manage that without, constantly tripping over each other, deleting work, or just descending into total chaos? It sounds like trying to edit the same document with 50 people at once. A nightmare. Today, we're diving into the tools that make this kind of collaboration actually work.
Yeah, it really would be chaos without the right tools. And those tools, the sort of unsung heroes, are things like Git and platforms like GitHub and GitLab. Our sources today, mainly from IBM technology, help us unpack these. They show how these systems provide, let's call it a shortcut to keeping teams in sync and managing all those changes effortlessly.
Right. So our mission today is to really clarify the differences, but also the synergy between Git itself and then GitHub and GitLab. We'll use a practical example, step by step, to show you how teams use them to build amazing things together, making it efficient and, dare I say, maybe even a bit fun. So let's set the stage first. What's the fundamental problem these tools actually solve? We touched on it, but this challenge of multiple developers working on the exact same code at the same time, how do you avoid conflicts?
That really is the core issue. Before tools like Git were common, it was genuinely a huge headache. Constant overwrites, lost work, painful merges. So Git and then GitHub and GitLab layered on top, they're the direct solution to that specific problem of concurrent development.
Okay, let's break down the players then, starting with Git. We hear version control system a lot, but what does that really mean? What is Git?
Okay, so Git, at its heart, is a distributed version control system. The distributed bit is important. It means the entire history of the project isn't just in one central place. Every single developer has a full copy, the whole history, right there on their own computer, their local machine. It primarily runs via the command line.
Ah, so it's local, it's powerful, it tracks everything on my computer. What about GitHub and GitLab then? Are they just like websites for Git?
They're way more than just websites. Think of them as hosted Git platforms. They live in the cloud, on the web. Yes, they host the Git repositories, the code itself, but they add a whole layer of really useful features on top collaboration tools, issue tracking, project management stuff, code review workflows. Plus, they foster huge communities, especially GitHub with open source. GitLab often pushes its kind of all-in-one DevOps platform angle. They make Git usable for big teams.
Okay, that makes sense. So Git is the powerful engine running locally, tracking your individual changes. GitHub and GitLab are the online hubs. They host the code centrally and provide all the tools needed for the team to actually work together around that code.
Exactly. It's a crucial distinction. Git is the foundation. GitHub, GitLab build the collaborative house on top of it. And together, they offer some indispensable benefits. First off, tracking changes. You know exactly what changed, who changed it, and when. It's incredibly detailed.
That detailed history must be amazing for debugging, right?
Yeah.
You can pinpoint exactly when a problem was introduced.
Precisely. And that leads to the next big thing, historical backup. Think of it like hitting save as constantly, but much smarter. Every time you commit changes in Git, you create a snapshot of your project at that moment. So if you introduce a bug or totally mess something up, you can just rewind, go back to the last working version. It's a huge safety net.
Okay, I can see how that removes a lot of fear from making changes.
Definitely. And then there's the core team-based development enablement. This is what allows, dozens or hundreds of people to work on the same code simultaneously. They work on different parts, different features, and then these systems provide smart ways to merge all those changes back together without chaos. Plus, it's flexible. You can work entirely locally if you want, or you can integrate it deeply into DevOps workflows for automated testing, building, deploying, the whole pipeline.
And the interaction is different too, right? You mentioned Git is often command line based.
Yeah. Traditionally, Git itself is used via commands typed into a terminal on your local machine, which is very powerful. But GitHub and GitLab offer these user-friendly web interfaces. You interact with them through a website, which makes things like code reviews or managing projects much more accessible to everyone on the team.
Okay, so to really understand the collaboration part, we need to talk about something called trunk-based development. The source uses a tree analogy.
Yes, it's a really helpful analogy. Think of the main line of code, the sort of official current version of your project, often called the main or sometimes master branch as the trunk of a tree. When a developer wants to add something or fix something, they branch off from that trunk. They create their own separate branch to work on.
Like a literal branch growing off the main trunk.
Exactly. They make all their changes safely on their own branch. Then, crucially, they merge that branch back into the main trunk relatively quickly. The idea is to keep these branches short-lived and integrate back frequently. Imagine two developers, both branching off the same trunk, making changes, and then merging back. Trunk-based development keeps everyone close to the main line.
Got it. Keeps things integrated.
Hmm.
So let's put it all together with our music player app example. We have a team building this app.
Perfect. So first, there's the repository or repo. This is just the project's home where all the code and its history lives. It's hosted on, say, GitHub or GitLab.
Okay, so I'm Nathan, one of the developers. I'm a big bluegrass fan. My task is to feature bluegrass on the homepage. First step, I clone the repo from GitHub to my computer. This downloads the entire project and its history. Then I create my own branch, maybe called Nathan Branch or Feature Bluegrass. This keeps my work separate. I start editing the code in my local working copy. I add the bluegrass section to the homepage. Once I'm happy, I commit my changes. This saves a snapshot of my work to my branch with a message like Add Bluegrass Feature to Homepage. Finally, I push my Nathan branch from my computer up to the shared GitHub repository. My Bluegrass feature is now backed up and visible, but not yet in the main app.
Okay, now here comes the interesting part. Your coworker, Greg, he's a rock music fan. He's working at the same time. Importantly, Greg also cloned the repo to his local machine, but he did it before your bluegrass changes were finished and merged into the main branch online. His starting point is slightly older. Greg wants to feature rock music, so he creates his own branch, let's say Greg Branch or Feature Rock. He makes his changes in his working copy, adds rock music to the homepage. Then he commits his changes to his Greg branch locally.
Okay, so now Greg wants to get his rock feature into the main app, but my bluegrass feature might already be in the main branch by now, right? What happens?
Exactly. This is where potential conflicts arise. Before Greg can merge his changes into the main branch, he needs the latest version of that main branch, so he'll do a pull operation. He pulls down the latest changes from the main branch on GitHub into his local main branch. Let's say your bluegrass feature was merged in the meantime. Now, when Greg tries to merge his Greg branch with the rock feature into his updated main branch, which now has bluegrass, Git will likely stop him. It'll say, hold on, both you and Nathan edited the exact same part of homepage code. This is a merge conflict. Git doesn't know which change to keep, rock or bluegrass.
Oh, okay. The system flags the conflict because it can't automatically choose. So what does Greg do? Does he have to start over?
No, not at all. This is where the developer steps in. Git marks the conflicted sections in the file. Greg opens that file, and he'll see both his rock changes and your bluegrass changes, clearly marked. His job is now to manually edit the code to resolve the conflict. He might decide, okay, let's feature both bluegrass and rock. He adjusts the code accordingly. Once he's fixed it, he makes another commit to save the resolved version. The conflict is handled.
Okay, he fixed it. Now how does he get it reviewed and finally merged?
Right. Now he submits what's called a pull request, often abbreviated as a PR, on GitHub or GitLab. The PR is basically Greg saying to the team, hey, I've finished my rock feature. I've also incorporated Nathan's bluegrass stuff and resolved the conflict. Can someone please review my changes before we merge them into the main code base?
So the pull request is like a formal request for review and integration.
Precisely. It's a central place for discussion. You, Nathan, or other team members can look at Greg's exact code changes. You can leave comments, suggest improvements, maybe automated tests run automatically against his changes. It's a crucial quality gate. Once everyone's happy and the PR is approved, then finally Greg's branch with both rock and bluegrass features gets merged into the main branch.
And boom. The main application code now has both features, seamlessly integrated. It shows how Git is the engine tracking versions, handling conflicts, while GitHub or GitLab provides the platform for that team interaction, the pull requests, the reviews, the final merge. It turns potential chaos into a structured process.
That's it exactly. Git is the foundation, the distributed version control. GitHub and GitLab are the collaborative layers, the web-based platforms that make large-scale team development manageable, even efficient.
So wrapping up, it's clear how vital this Git, GitHub, GitLab ecosystem is for software. But it makes you wonder, given how powerful version control, branching, merging, and review processes are for code, could these core ideas be applied elsewhere? Think about other complex collaborative work, writing books, scientific papers, designing buildings, maybe even legal documents. Could the discipline of branching for new ideas, committing changes clearly, and using pull requests for review prevent conflicts and maybe even boost innovation in those fields too? What could you, listening now, gain by thinking about your own projects, even non-coding ones, in terms of branches and merges? Something to think about.